Have you ever wondered why a rocket moves upward when gases are pushed downward? The answer lies in Newton's third law of motion. Newton described motion through three fundamental laws. Today, we will focus on the third law, which explains action and reaction. Whenever two objects interact, they exert forces on each other. These two forces always occur together. Newton's third law states, for every action, there is an equal and opposite reaction.
The action force is the force exerted by one object on another object during an interaction.
At exactly the same time, the second object exerts a force back on the first object. This is the reaction force. The action and reaction forces are equal in magnitude. Neither force is stronger than the other. They act in opposite directions. If one force points right, the other force points left. The other force points left. This is the cult. There is an important point. Action and reaction forces act on different objects. That is why they do not simply cancel each other. We can identify the pair as the force of A on B and the force of B on A and the B on A. Mathematically, the forces have equal magnitude but opposite direction. In vector form, one force is the negative of the other. Why don't these forces cancel? Because cancellation applies to forces acting on the same object. Action and reaction act on different objects. When you walk, your foot pushes the ground backward. The ground pushes your foot forward, allowing you to move. Running works the same way. You push the ground backward more strongly, and the ground pushes you forward. When you jump, your feet push the ground downward. The ground pushes you upward, causing your body to rise. A swimmer moves forward by pushing water backward. The water responds with an equal and opposite force on the swimmer. A boat moves forward. Its paddle pushes water backward. The water pushes the boat forward. A rocket pushes hot gases downward at high speed. The gases exert an opposite force on the rocket, pushing it upward. A rocket does not need to push against the air or ground. It moves because it pushes its exhaust gases backward. When an inflated balloon is released, air rushes out in one direction, while the balloon moves in the opposite direction. Another example is recoil. When an object is pushed forward, the device experiences an equal reaction force in the opposite direction. During a collision, each object exerts a force on the other. These forces are equal in magnitude and opposite in direction. When a hammer strikes a nail, the hammer pushes the nail, while the nail simultaneously pushes back on the hammer. A book on a table also involves interactions. The book pushes the table downward, while the table pushes the book upward. Remember, equal and opposite does not mean the forces cancel. They act on different objects. A common mistake is calling every pair of equal and opposite forces an action-reaction pair. The forces must come from the same interaction. To identify a third law pair, ask which two objects are interacting and what force does each object exert on the other. Newton's third law appears everywhere. Walking, swimming, jumping, boating, rocket propulsion, and countless everyday interactions. Remember four key ideas: equal magnitude, opposite direction, simultaneous forces, and different objects. Newton's third law teaches us that forces always come in pairs. Every interaction involves two objects pushing or pulling on each other.